I'm unmuted. Thank you. Thanks for having us. And folks, I apologize that I am not Selena Gray. Selena is our Assistant Director for Environmental Justice. She lives in Port Angeles, and life kind of ganged up on her this week, and I had to step in for her. So I'm afraid you guys are stuck with me. But I'll do my best to tell you a little bit about how we've used dogs, particularly with emphasis on rangelands and forests, but particularly for biosecurity and invasive species. Off we go. Feel free to screen grab or take photos of the stuff. Anything you can reuse for it, or ask me if you want anything, photos or anything like that. So our field, really the conservation dog field, was really born in the 90s, working on difficult species, species that you can spend a whole field season without ever seeing. These are just 3 examples but I'm sure all of you have lots of examples. And invasive species, particularly ones that haven't arrived yet, tend to be rare, low density as well. And so we've in the 90s, with the advent of new tools like fecal DNA, the idea was to try to start finding better ways to find wildlife, to learn about them, and of course to protect them. And this is what we landed on. It's a dog's nose. And a dog's nose really is the best chemical sensor that the world has ever known. And that's partly because it's very sensitive, but it's also because it's attached to a dog, and dogs will go with us wherever we want to work. They work for kibble or a ball, and they're very flexible. They learn very quickly. So many of you have seen a bird dog, or even many of you may have seen conservation dogs, and even some of you, our dogs work. It looks a lot like a bird dog. They quarter. An orienteer or a handler will walk a transect line, but the dog goes back and forth and covers a lot more ground than just that area. And in fact, we know that dogs, they're not searching with their eyes. They're searching with their noses. This is an image that Gemini, the AI, helped us produce. But we know that odors spread and spread out, and they can often spread quite long distances. This is also an AI generated image. But we've had dogs that will go up to 600 meters off of a transect line to detect a target, their target odor. Now that was a scat, it was a cheetah scat. But the point is, they're searching a much larger area because odor moves around. And in fact, what we can do is watch the dog's behavior, watch where they're searching and how they're searching, and it can tell us a lot about where those species are. And particularly in the case of mapping infestations, it can tell us where we need to do our control and things like that. But I'll come back to that sort of idea. So we've been around for quite a while. We're based in Montana, and this is our 30th year, 25th registered. And we've worked in a lot of places, and we've got a lot of dogs, and we do a lot of different things. But I'm really just going to focus on our biosecurity work. But the truth is, a lot of what I'm going to tell you isn't unique to invasive species or diseases or things that reproduce themselves. So some of it applies to ecological monitoring or law enforcement or other things as well. And the truth is, there are a lot more conservation dogs out there on the landscape now. Back in the day, in the 90s and the early 2000s, we were kind of our organization, but there are a lot more people doing this work, using a lot more dogs now, and that's wonderful. We think that's a great thing. The figure on the right is from a recent review. It wasn't our work, Grim Seyfarth, 2021. They found that dogs were better than other compared methods 89% of the time. And I always say that's not a very interesting result, because obviously you all know what methods work best out in the field, and often if you've gone to the trouble of incorporating using dogs, it's because you've exhausted other sort of methods. So yes, dogs can be good at this stuff. But the more interesting take on this is to look at when are dogs really effective. And this is a lot of the same studies. These are the bars represent the ratio between using the dogs, a non-conventional method, and whatever the conventional method was. That might be camera trapping, it might be distance surveys, it could be anything. And so we asked, when do you get the biggest bang for your buck? And I'm very happy that I'm not the first person to bring up catch per unit effort today. That's great. But the red line shows the CPUE ratio of 1. So that line shows when a dog is equal to the conventional method. And the fact that it's very low, that's not surprising because these are handpicked sort of data. But what we want to know are up at the top of the figure here, what are the circumstances where dogs really give you the biggest bang for your buck? And I'll cut to the chase and just tell you it's 3 things. It's very low densities, it's structurally complex environments, and it's cryptic species. And that's when you get dogs tend to be the best method and often the best by a long shot. That live rodent detection, that was 60 times the humans searching for them. Another interesting part of that is that dogs are also unbiased. So we as humans, we walk around with a search image in our heads, right? And we think we're always updating that, thinking, well, I know where I'm going to find the next plant or the next animal or whatever. And dogs don't do that. And so that's a dog in South Africa, and that little tortoise is a geometric tortoise. They are heavily trafficked. That little animal could sell for $10,000 in China. And people can be really good at finding geometric tortoises, but these small young age classes we're not as good at. And Bryn is really good at that. And it's because she searches with her nose and doesn't have isn't biased in the way that she searches. So she really nails it in finding those young ones. And I'm gonna come back to that idea a little bit later on as I wrap up shortly here. So just to come back to it, I'm really from here on out just going to talk about our biosecurity work. And we use that term biosecurity as an umbrella for invasive species, pest species. It could be, native species that are at high abundances or, people don't want them in places where they're not wanted. And it's also diseases. But for the purposes here, we'll just be thinking mostly about invasives. And over the years, we've used dogs on a lot of different species. That's spotted knapweed on the top there, brown tree snakes in Guam. I'll tell you a little bit about emerald ash borer. Those are zebra and quagga mussels, but we just this year started now training on golden mussels as well for reasons that were obvious from the earlier talk. And also fish. We can use dogs for fish as well. And I'll mention that briefly when we get there. And to be honest, I'm a landscape ecologist by training, not a invasive species specialist by any stretch. And honestly, when we started doing this work, I thought that all we were going to talk about was prevention. Can we use dogs to prevent propagules from being introduced or whatever? And in fact, we see dogs applied across this whole sort of spectrum. So I'm going to dive into one example and spend a little bit of time on one example from here in Montana that hopefully highlights kind of how it works with dogs and some of the ways that maybe you guys might be able to leverage dog work or take advantage of their talents. And that's from Dyer's woad. Dyer's woad's a noxious, considered a noxious weed. It's a Eurasian species. It was used for dye, as you can see from the colors there. That photograph is from northern Utah. We had a infestation in Missoula on Mount Sentinel. For those of you who've been there, Mount Sentinel is the mountain right next to the university in Missoula with the big M on it. And it's a beloved place, and people started seeing Dyer's woad there. And there was a little bit of effort in the 99 was the first year of data for it. And then all of a sudden it took off and people started to take it much more seriously. and they organized weed pull days and things like that. But all human searchers, people going out looking for the plant and then removing it. And they did pretty well. They knocked it back, the initial spike. But then after about 6 years of lower numbers, they just couldn't get rid of it. They couldn't turn the corner and eradicate the plant. So they asked us, we think maybe we're missing some plants here. Do you think you guys could bring a dog in? And we said, sure. And we brought Seamus. This is Seamus. Seamus is a very serious border collie. He's a rescue. He came from Heart of the Valley shelter here in Bozeman. And he learned how to find Dyer's Woad. And he was deployed. So he went out the first year and they said, we think we got all the plants. Let's bring in Seamus. We had another dog too named Tobias, who's worked on it as well. And we're now on the 3rd generation of dogs doing that project. But and Seamus and Toby came in and they found over 500 plants, over 500 plants that the human searchers had missed. And so they have continued to find lots of plants and knock Dyer's Woad back. So I'm just going to focus on and show you the data from these last few years. Those look like it's zero. It's not quite. But it's getting close. We're getting down close to zero. So in the first couple of years, we found in the hundreds of plants, and now we find a couple dozen every year. And that's Fenton. He's now one of the 3rd generation dogs, and that's a Dyer's Woad plant right there in front of his nose. And he is he's kind of giving us, tipping it off what the secret is, and you'll see it in the data there too. The trick is Fenton's great trick, and the great advantage of using dogs is we can send them out early in the year, and we get them out before plants flower and before they set seed. And that's really what's enabled us to get ahead of this infestation with the collaborators from the Missoula County Weed and Pest and the university, and this is a big effort. But the trick is to get out there and really mine the seed bank. These are seeds that have probably been in the seed bank for quite a long time, and now they're emerging, and we're able to remove them before they set seeds. So hopefully we keep doing this as long as they're viable, and then we'll have a few years of no recoveries, and that'll be that. And if you're not impressed yet by Fenton finding that little plant down in the rocks, here are some of the other plants that Seamus is no longer with us. He retired and lived till almost 17. But here are some of the other newer plants that they've found, and the dogs find these really little plants. And the point is, I don't want to belabor it too much. But going back to Bryn and the geometric tortoise, the trick is that by using dogs that use a different search strategy, that look using their noses instead of their eyes, we were able to sort of get ahead of the biology of it, and it opened doors to do things that we hadn't really thought possible beforehand. So over the years, we have worked on a lot of different. These are just invasive plants that we've sort of worked on, but we've also worked on a lot of different other sort of targets. So there's the emerald ash borer that we mentioned earlier. We not only work on ash borer, but we work on the larvae and the eggs. And we have a dog who identifies ash wood, so that we know what wood or mulch needs to be inspected. And that helps when people are moving things around. We've also got, there's a fowl. We do work on zebra and quagga mussels. I mentioned that. Rodent work on chips, feral swine. In the middle on the right there are Argentine ants. That's Lily, one of our veteran dogs, working on Lespedeza in Iowa. And then right there in the middle, that's Fenton. You saw him earlier working on Dyer's Woad. He also works on salt cedar and perennial pepperweed, and is going to start working on the name just ran away from me. I'll think of it before the end this year. And he does all of that work from boats. So it really opens doors to do stuff that we never really thought about, which is great, and to search in places that we hadn't thought about. And this is another example. That's Amy Hurt. She's one of our founders. That's Lily again. Lily was originally trained to do boat inspections for zebra and quagga mussels, both for the adults, you know, the mussels themselves, and for the veligers. If it's dried on a boat, they can detect that. They can detect as few as 6 veligers in a 10-liter bucket of water. But then once she learned it, we said, well, let's use them to look up on infrastructure and in the environment. So this is Canyon Ferry. Some of you may remember we had a scare here in Montana. eDNA picked up mussel DNA, and Lily was one of the dogs who went out and searched in the landscape and thankfully didn't find it. We also do live animal work. So that's Tobias. He was one of the early dogs. The dog is Tobias. Kai is the handler there. And they went to the Channel Islands to work with the Nature Conservancy and the Navy to both work on an eradication project for Argentine ants, and then on another island pre-eradication to map where the Argentine ants were and where the control strategies needed to be. That is Megan Parker, also one of the founders. That's Pepin. They were trained on live fish. So under the bank there, you could just see a little flash of silver. There's a fish in a fish trap there, and Pepin could detect it. And not only detect that there is a fish there, but detect it to species. So that's quite useful in terms of you know, they can move a little more quickly than electrofishing, and add a different component to it. And I mentioned this one. I put this slide in for 2 reasons. One is this is from our wolf work. We do genomic mark and recapture with wolves, just like mark and recapture, but based, you know, on DNA. So for species for which the genetics are well worked out and you can identify individuals, there's no reason you can't do the same to get population estimates. But I also wanted to include this slide because the woman on the right there is Jordan Little White Man Ortiz, who was our 4th native intern. And we do have a native internship program. Interns work on everything. That's an ecological monitoring project. But for those of you who know of students, we've had high school, college, and graduate students. In fact, Selena, who was supposed to be presenting today, was I believe she was our 2nd or 3rd native intern through the program. She did it as a graduate student. So as you know, people, we filled it for this year, but for subsequent years, if you know people, please speak up. Okay, okay. Dogs are also, people love to talk about dogs, and they love to see press about them. And so you can actually engage communities in different ways. And I won't go into it, but we combine dogs with lots of different technologies and have taken them in a lot of different places to then do other subsequent work that outside of the normal, what we normally sort of think about. And what's nice about that is the press often come to see the dogs and hear about it, and it's an opportunity. So yeah, they like to see them run on the treadmill there. It's often an opportunity to explain to policymakers and funders and people like that what we're up to and why we're doing it. And as you guys have mentioned with Clean Day and Dry and other things, it's important to not only, you know, get the word out, but do it publicly. And we can also use dogs and working in the communities where we're sort of working. So with that, I'll just summarize. There are lots of different ways that you can use dogs, and we would love to partner and to help others do it. And if I leave enough time there, I'll put this up so you can get my coordinates, but importantly also Selena's and Alice Whitelaw, who's also one of our founders, who does intake and designs new programs, and she's the first person you call if you want to have dogs. So thank you.